Hello friends, welcome back to our channel Aaj Zindagi Edu Care. Our channel provides online learning materials of maths and science from class 8th to class 12th. Please visit our channel playlist to get benefit of these free online learning materials. Okay friends, coming back to relations lecture, this is the third part of relations lecture. So till now we have discussed what is a ordered pair, Cartesian product of sets. Then we have discussed different types of representation of Cartesian product of sets. Also we have discussed some important theorems on Cartesian product of sets. Today we will discuss what is a relation. Then we will see different forms of representation of a relation. Then we will discuss domain and range of a relation and inverse of a relation. So those who have not gone through the previous lecture of this chapter or sets, please see the lectures. You may find the link in the description box or you can find the lectures in the playlist. Okay friends. So we will start with relations. What is a relation? Okay. To understand this, we may take an example. Suppose A and B denote the set of all male and female members in the royal family of Dashrath's kingdom. So we can write male members as, if we represent this using Venn diagram. See, if I represent using Venn diagram, okay. So in this we will write names of all the male members and then we will write names of female members. So here male, this is your set A and this is your set B. Okay. So here if we write all the member names, male member names, here we can see Dashrath, Ram, Lakshman, Bharat and Shatrughan. Okay. You may take some larger size so that it will come inside the Venn diagram. Okay. So next we will consider names of female members. Kausalya, Kekai, okay, Sumitra, Sita, Urmila, Mandvi, then Sruthkriti. Okay. So if we want to show the relation as male member as husband of which female member, we can show that Dashrath was husband of Kausalya. So by arrow we can represent then Kekai and Sumitra. Okay, he was husband of Kausalya, Kekai and Sumitra. Next we can see if we take Ram, then we can relate Ram and Sita, then Lakshman and Urmila. Bharat and Mandvi, and the last one Shatrughan and Shrutriti. Okay, so this we can write, and if we want to show this in the form of ordered pairs, we can write this relation as, see, Dasrath, first order pair, Dasrath, then Kausalya, next Dasrath, Kekai, next one, this is another Dasrath, Sumitra. Okay, next order pair, if we see or a relation Ram, Sita, Lakshman, Urmila, Bharat, Mandvi, and last one Shatrughan and Shrutkirti. Okay, so this is a relation shown in the form of ordered pairs. So we can clearly see if this is a set A and this is a set B. So if we write R is a subset of A into B, can we write? Because in A into B, even it will come like, if we take for example Ram, it will be related to each element or each member of set B. So we can clearly write that R is a subset of A into B. Okay. So this is a visual representation of relation by an arrow diagram. So it shows the relation was husband of from set A to set B. This gives rise to a subset R of A into B such that xy, if it is a subset, then we can write xy is an element of R if and only if x is related to y. Okay, x or y, so the relation between x and y. Okay, friends. So now we have seen what is the relation through this representation, or considering this example. Now we will define relation. So what is a relation? If A and B are two sets, okay, then a relation R from A to B, from set A, or we will write A to B, is a subset of A into B. Okay, thus R is a relation from A to B. It implies R is a subset of A into B. Okay, if R is a relation from a non-void set A to a non-void set B, and AB is an element of R, Then we may write A or B, which can be read as A is related to B by the relation R. So please note, if R is a relation from a non-empty set A, to a non-empty set B, and if AB is an element of R, then we write A is related A or B, which is read as A is related to B. A is related to B by the relation R. Okay. Thus, if AB is not an element of R, then we write if AB is not an element of R, then we write A, let A R, and we strike it B, and it is read as A is not related to B by the relation R, and is read as A is not related to B by the relation R. Okay. So if we take an example, suppose set A is given as 1, 2, 3, and set B is equal to A, B, C, and a relation is given by R equal to 1B, 2C, 1A, and 3A. Okay, it is a subset of A into B, is a relation from A to B. Okay, R is a relation from A to B and also a subset of A into B. So we can write 1B, 2C, 1A, and 3A. Okay, these all are element of R. So all these are element of set R, and is one is related to B, two is related to C, then one is related to A, and three is related to A. Okay, and we represent this. So we represent as 1 RB as It is defined by relation R. Okay, one is related to B by the relation R, then 2RC, okay, 1RA, and next one 3RA. So this are relation, and if we take 2B, now if we see 2B, this is not an element of R. Okay, 2B is not an element of R. So we write 2R and strike it. 2 is not related to B by the relation R. Okay, friends. So let me clean this. Next, we will see total number of relations. Total number of relations. Okay. So if A and B are two non-empty sets consisting of m and n elements respectively, then A into B consists of m n ordered pairs. Okay. So total number of subsets from A to B is 2 to the power mn, and among these 2 to the power mn relation, the void relation and universal relation A into B are trivial relations from A to B. So this we can write, if A and B are two non-empty finite sets consisting of m and n elements. Okay, A has m elements and B has n elements respectively. Okay, then A into B consists of m into n or mn ordered pairs. So total number of subsets of A into B, as we have seen in the set chapter, is 2 to the power number of ordered pairs, so 2 to the power m into n. Okay, so this is the total number of relations, possible relations. Next we will see representation of a relation. Different forms of representation of a relation. So let me clean this. Okay, so first one is roster form. First one is, as we have seen in the say, roster form. Those who are not familiar of this form, please go through the sets lecture. You may find this in our playlist. Okay, friends. So in roster form, a relation is represented by set of all ordered pairs belonging to R. Okay. So if a set R, or we write if R is a relation from set A to set B, set A which is given as -2, -1, 0, 1, 2, to set B, okay, which has elements as 0, 1, 4, 9, 10, 11. Okay, by the rule A R B, the rule is A square equal to B. Okay, thus it can be written as 0 A square equal to B. So 0 R 0. Then next one will be -2 R 4. Then -1 R 1. Then we can write 1 R 1. Okay. Next will be 2 R 4. So this is a relation. So we can write R is described in roster form as, we can define this in roster form 0 0. This is first order pair. Next will be -2 4, -1 1, 1 1, and last one 2 4. Okay, this is a roster form. Okay friends, next form is set builder form. So in this form, a relation from set A to B is represented as, we can write relation R from set A to set B is represented as R equal to AB, such that A is an element of set A, B is an element of set B, and AB satisfy the rule which associates A and B. Okay, so this is the set builder form. If we consider an example, if A is equal to 1, 2, 3, 4, 5, and B is equal to 1, 4, 9, 16, 25. Okay. So R in set builder form we can write as R equal to A, B such that A is an element of set A, B is an element of set B, and B equal to A square. Okay, this so B equal to A square shows relation between A and B. So this is the set builder form. Next, we will see another representation which is arrow diagram. So let me clean this. Third form is by arrow diagram. So in order to represent a relation from set A to set B by this method, we draw arrows from first component to the second component of all ordered pairs belonging to R. So we can write in order to represent a relation from set A to set B. From set A to set B by an arrow diagram. We draw arrows from first component to second component of all ordered pairs. Okay, belonging to set R. Okay, so if we see an example, for example, our set R or relation R is given as 1, 2, 2, 4, 3, 2, 1, 3, and 3, 4. Okay, this is a relation, and set A is given as 1, 2, 3, 4, 5. So R is a relation from set A to set B, and set B is given as 2, 3, 4, 5, 6, 6, and 7. Okay. So if we try to represent by arrow diagram, first we will draw set A. Okay. So set A we have set 1, 2, 3, 4, 5. Okay. This is our set A. Next we will draw set B and write all the elements inside it. 2, 3, 4, 5, 6, and 7. This is set B. And if we see all the ordered pairs of set R, 1 is related to 2. So 1 first will link it to 2. Then 2 is related to 4. Okay. 3 is related to 2. Okay. 4. So 1 is again related to 3. 1 is again related to 3. And 3 is also related to 4. 3 is related to 4. So by this way, we represent relation from set A to set B. Okay, friends. So we will see next type of representation. Let me clean this. So fourth type is bilattice. Okay. So in this form, a relation R from set A to set B is represented by darkening the dots in the lattice for A into B, which represent the ordered pairs in R. So in this form, relation R from A set A to set B is represented by darkening the dots. Now darkening the dots in the lattice for A into B, which represent the ordered pairs in R. Okay. So if we consider an example, if set R, or we can write if relation R is equal to minus 3 9 minus 2 4 minus 1 1 0 0 1 1, then 2 4 and 3 9. So A square equal to B, that is the relation. So it is a relation from A to B where set A is minus 3 minus 2 minus 1 0 1 2 and 3, and set B is 0 1 2 3 4 5 6 7 8 9. Okay. So R can be represented in the form of lattice by, so what we do, as we have seen in the graphical representation of Cartesian sets, okay, like that we will draw set A on the horizontal line and set B on this vertical line, y and y dash. Okay, then we represent, so first we will write all elements of set A on the horizontal line. So it will be 1 2 3 Okay, here it will be 0, then minus 1, minus 2, and minus 3. The divisions are not to the scale. Okay, then we represent on vertical line set B elements, okay, which are 0 to 9. So here it will be 0, comma 0, x and y, then 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so next we will draw dotted lines to form the lattice for all the elements. Okay, so this is 1, then this is minus 1, minus 2, minus 3. Okay, then we can draw similarly for 1, 2, and 3. Now these are elements of shade A. Shade B also we will draw this one. This is for 1, this is 2, 3, 4, 5, 6, 7, this is your 8, and this is your 9. Okay, we can denote it 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so now if we see R, so minus 3, 9, so it will lie here. We will denote it by a circle, darkened circle. Okay, so this is minus 3, 9. Second one is minus 2, 4. So minus 2 is here. So 1, 2, 3, 4. This one, this is your minus 2 and 4. This order pair. Third is minus 1 and 1 will lie here. So this is your minus 1 and 1. Next one is 0, 0. It will be here. After that 1, 1. This is 1, 1, 1, 1. Next one is 2 and 4. It will lie here. So we can denote as 2, 2 comma 4. And the last one is 3, 9. So 3 and 9. R can be represented in lattice form by this way. Okay. So next we will discuss domain and range of a function. So let me clean this. Domain and range. Okay. So if R is a relation from set A to set B, then all the set of first components or coordinates of the ordered pair belonging to R is called the domain of R, while the set of all second components or coordinates of the ordered pair R is called the range of R. So we can write if R is a relation from set A to set B, then set of all first components or coordinates of the ordered pairs belonging to R is called the domain of R. Okay, domain of R. While set of all second components or coordinates of ordered pairs in R is called the range of R. Okay, so this is what domain and range is. So if R is the relation, then we define domain as domain of R is equal to A such that AB is an ordered pair, okay, which is an element of R, and range of R is defined as B such that AB is an ordered pair of set R. Okay, so by the definition, domain of a relation from A to B is a subset of A and range is a subset of B. So domain of R is a subset of set A and domain of range of R is a subset of set B. Okay friends, if we consider an example, see if set A is given as 1, 3, 5, 7, 9. Okay. Set B is given as 2, 4, 6, 8, 10, 12. And R is a relation from A to B. It is given as 1, 8, 3, 6, 5, 2, 1, 4. Okay. So here if we see domain of R is equal to 1, 3, 5 and range of R is 8, 6, 2, 4. Okay, and if we see domain of R, that is 1, 3, 5, it is a subset of set A because A has 1, 3, 5. In addition, it has two more elements 7 and 9, and range R is a subset of set B, because if we see 8, 6, 2, 4 are in B and B has some additional elements. Okay, friends. So we will solve the problem based on this. If R is a relation from set A to B, set A is given as 2, 4, 5, and set B is given as 1, 2, 3, 4, 6, 8. R is a relation from A to B and is defined by X, R, Y, which implies X divides Y. Okay, so we have to write R as set of ordered pairs. Write this is first one. Write R as set of ordered pairs. Second one, find domain and range of set R. Okay, so we will solve first one. See, X is related to Y such that X divides Y. So if we see 2 will divide 2, so 2 are 2. 2 will also divide 4, 6 and 8. So 2 are 2, 2 are 4, 2 are 6, 2 are 8. Next is 4. So second element if we see 4 will only divide 4 and 8. 4 are 4 and 4 are 8. 5 will not divide any of the elements of B. So R can be written as in the form of ordered pairs 2, 2, 2, 4, 2, 6, 2, 8, 4, 4 and 4, 8. Okay. Now we have to find the domain and range. So by seeing the ordered pair, we can find domain of R is equal to 2, 2 is repeated and then 4. Okay. And what is range? Range of R is 2, 4, 6 and 8. Okay friends. So you can note down relation on a set. Relation on a set. So if A is a non-empty set, then relation from A to itself, that is a subset of A into A, is called a relation on set A. So please remember this definition, as in some problem it may be given that A is related to itself. Okay. So next we will discuss inverse of a relation. So let me clean this. Inverse of a relation. So we have seen domain and range. Then what is inverse of a relation? So if A and B are two sets and R be a relation from set A to B, from set A to set B, then inverse of R is denoted by R inverse. Okay, we denote this is a relation from B to A. Okay, and is defined by R inverse equal to BA such that AB is an element of R. Okay, so in this we can clearly see AB is an element of R, and if we write reverse the ordered pair from AB to BA, it will be an element of R inverse. Okay. Also we can write domain of domain of R equal to range of R inverse, and range of R equal to domain of R inverse. Okay friends. So if we see a example on this, if set A is given as 1, 2, 3, and set B is given as A, B, C, D, E. Okay, and R be a relation from A to B, which is 1A, 1C, 2D, 2C. Okay, this is a relation from A to B. A to B. So what will be R inverse? So find R inverse. So what we have to do? We have to just reverse the order of set R. So domain of R, or first we will write also here find domain of R inverse and range of R inverse. Okay. So first we will find R inverse, and in this what we have to do, we have to reverse the order of R, elements of R, that is in place of 1A it will be A1, then C1, D2 and C2. Okay, so this is our R inverse, and if we see domain of R inverse, it is equal to A, C, D. Okay, and this is equal to range of R. Then we can find range of R inverse. This is 1 and 2. Okay, and this is your domain of R. Okay, friends. So let me clean this. So we will solve a problem on the inverse. Please write down. If R is a relation defined by less than from A, set A is given as 1, 2, 3, 4, 5. Okay. To set B, it is defined as 1, 4, 5. So write down set of ordered pairs of R and find R inverse. Okay. So how we proceed here? See, it is given the relation is if xy is an ordered pair of R, it is an element of R, and it is given as x is less than y. Okay, where x is an element of A and y is an element of B. So from the given elements of A and B, we find we will start from the first element. So 1 is less than 4, 1 is less than 5. Okay. Next we will check with 2. So 2 is less than 4 and 2 is less than 5. Then we will check with third element 3. 3 is less than 4 and 3 is less than 5. Then we will check with 4. 4 is less than 5. Okay. So these are the possibilities. So ordered pair 1, 4 is an element of R. Similarly, we can write 1, 5 is then also an element of R. Then 2, 4 is an element of R. 2, 5 is an element of R. 3, 4 is an element of R. Then 3, 5 is also an element of R. And 4, 5 is an element of R. So in set form, we can write R is equal to 1, 4, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5, and last one is 4, 5. Okay. Then we have to find R inverse. So R inverse, we will just inverse the ordered pair. So 1, 4 will become 4, 1, 5, 1, 4, 2, 5, 2, 4, 3, 5, 3, and 5, 4. Okay. So if we define R inverse, we can write this equal to x, y, such that x is an element of B, y is an element of A, and x is greater than y. Okay, friends. So we have represented this in the shape builder form. So today we have discussed what is a relation. We have seen through examples. Then we have discussed different types of representation of relations. Also, we have discussed domain, range, and inverse of a relation. I hope all of you have understood this lecture. If you have any doubt or any query related to this lecture or this topic, please let me know in the comment box. I will try to resolve your doubts. And if you have seen the whole video and you liked it, please like the video and subscribe our channel Aha Zindagi Edu Care. Also press the bell icon button so that you will get notification when next video will be uploaded. Okay friends, thank you.